Okay, so for this problem, number 31 from the homework of 12.2, this talks about the Pythagorean identities. And these turn out to be some of the most important identities in all of trigonometry and will get used over and over and over again. And so they give them to you and they say that you've got sine squared of theta plus cosine squared theta equals 1, and then tangent squared of theta plus 1 equals secant squared of theta, and then 1 plus cotangent squared of theta equals cosecant squared of theta. So there's really two important parts for understanding this problem. The first is making sure that you understand why these identities are true and where these identities come from, the most basic one. We can do that by thinking about just the triangle, a basic Pythagorean or right triangle where you have this is A, this is B, and this is C. And from this, we know that A squared plus B squared equals C squared. But if we divide all of this by C squared, we get A over C squared plus B over C squared equals 1. And so we just divided through by C squared. Well, A over C is the same as sine of A. And B over C is the same as, the adjacent over hypotenuse, which is cosine of A. So that leads us to this idea that sine squared of A plus cosine squared of A equals 1. Now, just in case I haven't gone over this before, make sure you know that this right here is synonymous with this. Sine squared, it's just a shorthand way, and rather than having to do the parentheses and the square, we don't want to put the square on the theta because we might get confused. Are we squaring the angle or is the whole thing squared? And so we put that on the sine part, but that just means sine of theta times sine of theta. Whatever that value is, you square it equals this. Okay, well, once you establish this one, sine squared of A plus cosine squared of A, you can find the rest. Well, because if you have tangent squared of theta, well, tangent is sine over cosine. That was proved in your assignments. If you're not sure about that, make sure you know this. Sine of theta, or not sine of, tangent of theta equals sine of theta over cosine theta. That's a really important identity. It's easy to see that as well. Tangent of theta would be A over B, and sine of theta is A over C. Cosine of theta is B over C, and so the C's cancel out to give you that tangent of theta equals sine theta cosine theta. So to do this, all I need to do is take my Pythagorean identity, divide through by one of the two functions. So if we divide through by cosine squared, we get sine squared of theta over cosine squared theta plus cosine squared theta over cosine squared theta plus 1, or equals 1 over cosine squared theta. Well, sine over cosine is tangent, so that becomes tangent squared theta. This is just 1 because those cancel out. 1 over cosine squared theta is the reciprocal of cosine squared theta, which we know is secant squared theta. And then you do the exact same thing for cotangent, but instead of dividing by cosine, you divide by sine, right? If we divide this Pythagorean identity, basic Pythagorean identity by sine squared, we get sine squared theta over sine squared theta plus cosine squared theta over sine squared theta equals 1 over sine squared theta. Well, this is just 1. This is the reciprocal of tangent. Cosine over sine is sine over cosine is tangent, so the reciprocal is cosine over sine, which is equal to cotangent. And then 1 over sine squared theta is just going to be cosine squared theta, or cosecant squared theta. The reciprocal of sine is cosecant. So that gives you 3 different identities. These become useful at different times and are important to know.